Hello everyone, I'm Sarikesh and I'm here to represent my team A5P, and I'll be the one explaining our hackathon submission, which is an Android application called RoadFlow-Ai. And since it's a software solution for a real world problem, let's overview the problem first. So okay, think about it. Every single day lakhs of people are traveling on the roads that are fully damaged, and these pothole and cracks, it's not just some small discomfort, right? It actually causes accidents, it damages the vehicles, sometimes it even takes lives, and the government is also spending crores every year just for repairs and claims. But the real problem is this: the system that is supposed to fix all this, it's basically blind and very slow. Everything is reported manually, like you call someone or you fill a complaint form, maybe you tweet about it. There's no proper way to measure how bad a road actually is. Drivers also, they don't get any warning, and the officers, they can't decide which road to fix first. So what happens is citizens keep hitting the same pothole again and again. Drivers have no idea and officers are just guessing. Basically, the whole feedback loop is broken. So this is where our project RoadFlow-Ai comes in. And the whole idea is we close this broken loop fully using just one smartphone. It's very simple. A normal citizen just point the phone at the road, and we have an AI model that is running completely on the device itself. No internet needed, and it detects the potholes, the cracks, manholes in real time. And immediately it calculates something we call the road health index. Basically a score from 0 to 100 that tells how bad that road is. Now that score, along with the GPS location, goes to the cloud, and it does two jobs at the same time. One, it warns the driver, it gives them the route that has the least number of hazards, and also a 50-meter proximity alert before a pothole is given. And two, it helps the officers, they get a live dashboard. And the best part is, after they repair the road that is damaged, which has been reported by a citizen, it will be verified by our AI gatekeeper and will only close the ticket if a fresh scan gives a full 100 score of the clean repaired road. So no forms, no guessing, just sense, score, route and verify. Everything automatic. We want this to be at low cost and work offline. So for the AI part, we use YOLO V8 Nano, and we converted into TensorFlow Lite. So it can run in milliseconds directly on the phone, so that no server will be needed for detection. The app is native Kotlin. We use Camera X for live camera. For real-time cloud, we use Firebase real-time database, so all reports sync instantly between citizen, driver and officer. For maps and routing, we use Google Maps, Places and Direction API. We also do PDF report generation on the device itself. And one thing, all the API keys and secrets are kept in environment variables. Nothing is hard-coded, nothing is exposed. So this is our architecture, and it basically has three stages, following the data from the road till the actual repair. First stage, the edge sensing and interference. This is on the citizen's phone. The camera gives frames to our on-device YOLO V8 Edge AI through TensorFlow Lite. It detects the damage. See here, it caught a pothole at 0.87 confidence. Then it calculates the road health index with zero latency. Right here on the phone, nothing goes out until we already have the result. The second stage is, this is a real-time cloud and routing core. That live RHA and GPS payload goes into a Firebase real-time database, which is like the single source of truth for us, and it is connected to the Google Maps and Places API, and it feeds our dynamic GIS route optimization logic. This is the part that decides which route is the safest one. The third stage is conception and zero trust verification. This is where the data actually becomes action. The driver, he gets this AI weighted polyline, basically a route that avoids the known hazards, plus the 50-meter proximity alerts. The officer, he gets the municipal GIS dashboard with all the open issues. And when someone claims a repair is done, our AI gatekeeper will demand a whole 100 score verification scan before it generate a repair ticket and closes the loop. And that is this verified ticket resolution going back into the system. So basically, it's one complete self-correcting cycle: detect, score, route, verify, and resolve. So now I'll do a little demonstration of a working prototype that we built. As you can see, this is the landing page of our application. There are two main parts that you need to focus, which is login as driver/officer and report a damage. As I explained before, initiation of this app begins from reporting a damaged road. Let's say I'm a civilian and I see a damaged road ahead of me. So I clicked reported damage, and this takes me to another page where it explains capture or upload, which has two specific buttons. When I click take photo, camera opens so that I can take a photo of the reported damaged road. But now, since we are in a enclosed sphere, I'll just upload from my a pic that I downloaded from Google. As you can see, the RHI report has been generated. From the picture, the AI model has analyzed the road with 5 potholes in it, and the overall damage being 25 out of 100, which is a poor report. And I'll just click submit report, and just like that, the damage report has been uploaded to the cloud. And then if I want, I can also download the report as a PDF, which will be saved. And now let's move on to the next main part of this application, which is the login. There are two types of logins for this, which is just a demo for now. If you log in as a driver, a 2D map using Google Map API will be opened, and then just like Google Maps, we'll just search a place to go. Okay, so now based on our RHI and route optimization algorithm, our application has paved a safe route for us to go based on road quality. And since we don't have much reports right now, since it's just an prototype, we haven't made much reports. So this is the generic safest route. Now when I click start navigation, as you can see, it's just like Google Maps, but we have to still develop a small navigation pavement along with this. And now let's move on to the officer panel of this page. Yeah, right now you can see that here's the report I just made. Just this 5 autos RSA 25. An officer can look at the whole map and look at the overall reports, and also there's a panel here to verify. If the officer is done with the road and the road is clean, the officer just have to open this panel and verify it. Road is in an enclosed. We currently don't have any road before us, so let's just say for debug purpose, we will clear an empty just road in it. So it will analyze and the report will be revoked just like that. So this is our prototype submission, and we still need some guidance to make it into full production. Thank you.